I started coding very early. In high school, my first language was C. Just got very kind of obsessed with.
So, what is the best way for people to understand ephemeral rollup?
When I got into crypto and blockchain, I realized the insane computing power that you need for training a large language model. I just felt like I could contribute more into crypto. You have this impression that everything is broken and you can build your own way, like you can be very impactful. Every day there are like 10, 15 ideas that if you take on it, you probably will be very, very impactful if you ship it.
Hello, hello, hello. Welcome to another episode of the OnlyDevs podcast. Today we have with us my good friend Gabriele from Magic Block. Welcome to the show, Gabriele.
Thanks for having me. It's a pleasure.
Awesome. Um, so we like to do this thing where we talk about the journey of the founder. So if you could, I know you used to work in AI and then you made your transition to crypto. Do you want to talk about it? Like, how did you get into crypto?
Yeah, absolutely. I guess I can start from the origin very quickly and then go till today where we are at. But yeah, I started coding very early. In high school, my first language was C. Just got very kind of obsessed with knowing how things work, how to fix stuff, how to build things. And then after that, it's that time in your life where you have time to experiment. And so I started building apps for mobile. At that point was Java for Android, and I published some of those on mobile, on Play Store, App Store, and after that I kind of I was building games. That was like my kind of passion in high school. I was building and try to kind of get a game working and experimenting with different tech stacks. That was kind of like my initial parenthesis. And after that, I did a major in computer science, specialized in AI, in Italy, in the University of Turin. And after that, I joined a startup. In this startup, they were basically offering the Wi-Fi, the guest Wi-Fi in big venues like airport or big shops, big venues, and their core product was basically indoor geolocation. So they had this sophisticated solution where a neural network was triangulated the signal of the receiver, mostly like cell phones, and getting a precise estimation of where people were navigating into an indoor environments. And on top of that, there was a analytics and extracting data, so you could observe common pattern or where people were going to a venue where they were spending most of the time, so things of this nature. And it was a interesting work. After that, I joined IBM Research. Initially, I was working on AI for fraud detection in the healthcare system. And in research, as almost like a startup, but with the funding of a big company. So you work on multiple projects. So after this work on fraud detection, I've worked on using language model for protein discovery and material discovery. So given certain properties that you're trying to optimize for, predicting a protein structure that then they will synthesize in the lab, and you will rank using this AI model the most likely candidate that will then have that given properties. And different other things, I've been working on symbolic reasoning, and it was pre-ChatGPT release, so it was interesting times where transformers started to be kind of widely adopted, but it was still to a certain level niche. So there was a lot of experimentation, how you train a model, how you empirically get fast, clean training data, and all of the optimization of that nature that I guess by now are kind of pretty standard. And that's also when I got into crypto and blockchain. I realized the insane computing power that you need for training a large language model. And I was experimenting with federated learning and distributed model training, and that's when I kind of got into crypto and blockchain as a way to kind of build the orchestration layer of how you train this sort of distributed model. Unfortunately, it's more like, I guess, like a project that works better in a startups. Like big company cannot take a risk and launching a coin, or everything is like highly sensitive to the policy of the company, and so I didn't manage to push it forward. But like it was my entry point in that, and yeah, anyway, I just got interested in Bitcoin first, the white paper, fall in love with it, Ethereum. I've been like, I was doing some experiment in Solidity, and then eventually like stumbled upon Solana. Just got interested about the tech, and quickly also kind of experimented with it, how fast and cheap, and got the idea of where the vision of Solana was going. And therefore, like, I started like taking vacation, going to hacker houses. There were like this 1 week event that Solana was doing at the beginning of where they were pushing the ecosystem. So I was taking 1 week vacation, going to those events, and then at some point in one of those hacker houses, that's when we started. I guess we can go deeper into that later.
Yeah, and also I think see this pattern where, interestingly, Tolly also, used to uh, during the early case of the deep learning case, there were a lot of these GPUs. So the story of Solana is also that now that you have this so much GPU, can you actually uh, build a, a blockchain that leverages these GPUs, right? So there's like a lot of interesting folks who have used to be AI adjacent or used to build infrastructure for AI and then are in block. So switching gears to Magic Block, right? So I remember the first time we spoke to each other, or got in touch was when you guys were running speedrun, and also you had this Unity SDK for people to build games. So today it's like Magic Block is its own roll up, if I may call it. It's a network extension on Solana. You guys are building ephemeral rollups. So can you talk about the how you got into this crawl space, and what Magic Block is doing today?
Yeah, absolutely. Yeah, I guess I can continue the story. As I mentioned, like in one of these hacker houses, we initially started building a project that then like evolve over times, and then becomes Magic Block. But yeah, the story is like I was, as mentioned, going to these hacker houses, and one of them was in Dubai, and my co-founder Andrea was living there. So I just like reached out and knew it was working on in crypto. It was like working on one of the first bridges between Bitcoin and like several other chains. So I just like reached out, hey, I'm coming. Are you going to the Solana hacker house? And that's when we started kind of building. We started with a game, and we didn't want any trade-off in using an API. Like I didn't want to experiment with the blockchain and start by integrating an API in a game. I wanted to kind of build, serialize, create a transaction, sign the transaction completely within the game, and then directly send the transaction to the blockchain. So it was a simple game, sort of a Pokemon Go, where you go around, mint NFT, validate GPS coordinates. But I was still fairly early in Solana. Like the SDK tooling was almost like frankly broken, and there was a lot of places where you kind of had to fork the repository, go into the source code, and implement your own solution. And so during that hacker house, I ended up forking. There was like an existing SDK for Unity, but it didn't work. So I kind of ended up forking it, and then like forking other libs. And by the end of the hacker house, like we almost like re-implemented the SDK completely, and we managed to make it work for like signing, creating transaction in game, and like ship the basic version of the game. But yeah, end of the story is this SDK we decided to open source it after the Akiraus, and it got traction. There were teams that were kind of looking for something similar. They wanted to build their own like on-chain game. They didn't want to take a trade-off of using an API, and so it got traction. Other people started using it, partially contributing, and then we got a grant from Solana Foundation to kind of continue improving and working on the Unity SDK, which is still available today. Still MIT, like we maintaining it best effort, but like gladly now the community is also supporting it, sometimes fixing bug and opening pull requests. And so that was the origin story. At some point, I kind of decided, okay, let's do the jump, and I left my job at IBM, not because I didn't like it. It was amazing, like super interesting stuff, but I just felt like I could contribute more into crypto. Like you have this impression that everything is broken and you can build your own way, like you can be very impactful. Every day there are like 10, 15 ideas that if you take on it, you probably will be very, very impactful if you ship it. And so from there, like we went full time with the idea of building fully on-chain games. And so it's a still fairly niche category of games where all the state and the state transition are completely on-chain, no API, no off-chain logic. And it was bear market, so even if there was like not many transactions, no congestion, we reached the limit of what you could do on the L1. Essentially, like even using interest lot, process commitments, and all of the optimization that you can do with the existing infrastructure, you could then get to the end-to-end latency that for certain category of games will feel kind of natural for the user. And so that's when we kind of went back to the wide world and decided, okay, let's try to build something that will still be aligned with the vision of like a fully decentralized machine, and still be composable with the ecosystem, but at the same time allow us to get end-to-end latency, real-time performances that is in pair with what would be a server for a game or an application. And so this was summer 2023, and at Breakpoint 2023 we presented Ephemeral rollups are all you need, which kind of outlined the design of what we call ephemeral rollups. So it's this solution that essentially can take a subset of the state from Solana. It clones just in time the smart contracts and all the readable accounts, and then it could operate with low latency on the accounts that are delegated to one specific instance. And it also has like an architecture that allow basically to co-locate this just-in-time instances close to the user. And so if you process a transaction in between 1 and 10 milliseconds, and you're close enough to a machine end-to-end, you can stay below 50 milliseconds, and that's when you kind of unlock the new category of games and apps that require this latency. And yeah, there was like, when we presented the first time, rollup was still like I think not a word that you will heard in the Solana ecosystem. Still nowadays it's kind of like a bit orthogonal to the vision of Solana, but because of like the nature of the ephemeral rollups, basically we think we found a way to basically be aligned with the overall vision of bringing a state machine that is global, and at the same time have like the scalability and the latency that you need. I guess finally, like if I have to describe the solution to a developer, I probably don't use the word rollup. I will describe it as a multi-threaded application where your Solana program is the main thread, and it can then dispatch computation to other threads that are executing these fast collocated SVMs, and then they can collect and get back the computation, and they can kind of orchestrate the flow and the logic of the application from the main thread, which is the Solana smart contracts. And yeah, so then going, I guess, fast forward to February the next year, and I guess to today, there was like a huge Solana congestion, mostly because like Solana was not performant as it is today. There were like several issues like related to RPC and like different part of the stacks, which now are way more solid and scalable. But anyway, we got kind of interest from several other use cases, not gaming related, that required kind of the same properties. And so we kind of evolve, even if we build already with the idea in mind to make it in a way that's general and scalable, we evolve to supporting like other use cases, like high frequency trading or deepin, and that's where we are today.
I have a question, Gabriel. What is the best way for people to understand ephemeral rollup, right? Because especially on the Ethereum side of the world, there's like a variety of rollups. So within that niche, what exactly does an ephemeral rollup mean? And also, especially within the context of Solana, I think Austin tweeted sometimes saying most rollup like things on Solana are better thought of as network extensions than L2s or rollups. So where exactly does Magic Block fit within this rubric, or is it something entirely different?
Yeah, that's a very good question. We actually had a very hard time when we were like coming up with a name. Okay, how should we call it? It's like a decentralized engine. It's like, is it a roll up? Is it something else? And then we ended up like choosing ephemeral rollups as like a best way to describe it. But like you're saying, mostly it's a very unique solution. I don't think there is any architecture that it is sort of like equivalent. Maybe state channel are the closer architecture to ephemeral rollups, even if they don't have a full VM. So ephemeral rollups do have a full SVM. You can run arbitrary smart contract within ephemeral rollups. But I guess the closer comparison in traditional like architecture would be state channel, and yeah, as you pointed out, like Austin Federa pioneered this network extension, and we were like one of the company and like solution that they mentioned, because like essentially there was a need to describe this new category, and there was no real like term or name that will fit perfectly what we were building, and I guess partially that's due to the fact of like architecting from like a Solana native perspective. Like I think initially we didn't look too much into all the existing like L2 architecture. We just told from first principle what would make more sense with a SVM architecture as a way to kind of get low latency real time performances. And there are a few unique characteristics of the SVM that makes our architecture possible, and it wouldn't be possible on EVM. And just to name a few, sometimes like this sounds like smaller difference, but they're actually huge in their compounding effect. Like the separation of the like the account model and the separation of the state and the logic is core of the parallelization, the mechanics that is within the block in Solana, but it's also core of our solution, because basically if there's no state contention, you can execute in parallel transactions that don't write to the same state, and it's fairly easy for a sequencer to like parallelize, because all the transaction declare upfront all the state that a transaction is writing and reading. So there's account model where everything is like an account, it's just data buckets, it's just a bunch of bytes, but smart contract are a specific type of accounts that are only readable. They contain the logic of your smart contract. You can potentially just like clone it just in time, clone it locally, clone it everywhere, and execute the same logic, which is stateless in any SVM runtime. And all the smart contract control state only indirectly through PDAs, program drive addresses. And so you only care about who has ownership and who can change those PDAs. And so the core idea is that instead of moving everything to a rollup, we can basically just lock and delegate a subset of those accounts. And then the ephemeral rollup will basically be able to clone just in time the logic, the smart contract, then execute the same logic for doing state transition on that subset of the state, which you can then independently commit and settle before unlocking those PDAs. And yeah, that's kind of like one of the core differences that make our architecture possible. Another big difference is that Solana is actually fast and cheap, and so it can actually be used as an execution runtime, and it actually should be used for anything that is critical. And as I was mentioning, like we see ephemeral rollups more like a multi-threaded Solana smart contract, where you still use your main thread, your like smart contract on Solana for all the critical logic, and then you can get this extra fast and cheap sometimes thread that are used to bring what will be impossible otherwise. So rather than like trying to have an alternative to what is actually running on Solana, we're trying to kind of unlock the new generation of apps and games that are not possible today, and we think are going to be on chain in the next 1-2 years.
I think one analogy that jumps to my mind is, for example, in a typical Web2 architecture, when you have a database and you have very specific hotkeys that are extremely read heavy, you would take them and put them on a cache. So this is kind of like the inverse version of it, where you have specific hotkeys which are write heavy, and you kind of know the access. These access patterns are predictable, and you want very high performance, so you want to put them on you want to delegate write access and put them on a separate environment so that you could do much more faster. So this is kind of like in the Web2 world, you would have cache, like you would have Redis or Memcache in front of your database, but in the Web3 world, instead of read for writes, you have these delegated accounts on an ephemeral rollup.
Yeah, I think that's a great analogy, and as you pointed out, like you can know beforehand like the pattern of what accounts are kind of hot account that you're often writing. But another like interesting pattern that we're seeing is that because this delegation is part of your smart contract logic, this could also be dynamic. Like you could record how many, like the frequency of a given extraction on mainnet in a time frame, and if this exceeds a certain threshold, then you offload the work. Otherwise, you just run it on mainnet, and so it gives you like an interesting kind of design space where you could kind of know upfront what most likely is gonna need low latency or some kind of extra features, and then run it in the ephemeral rollups, or it could be dynamic and encoded in your smart contract, and everything works transparently. And you can also go back, like in case you wanna CPI into another smart contract, then that's when you kind of bring back the account's normal state, and then you remain composable. If you're like operating in a isolation, then you can like bring it in, do state transition, close it, and then do something else. So yeah, it opens up the design space. That's absolutely a good analogy.
Awesome. And also keeping up with, I mean, it's kind of like, now on the Solana themselves are working extremely hard to, increase bandwidth and reduce latency. So in a way, it's like you're also like working in your own way to do that. So that must mean you're dealing with like extremely hard engineering problems. So I'd love for you to talk about some of these, hard engineering problems that you are, tackling at Magic Block.
Yeah, yeah, absolutely. We have a lot of interesting, I guess, problem and in different categories. Um, a category of problems are around synchronizing with Solana state because like it's a insane like number of accounts and state transition that are happening all at once. Like you need to basically keep track and selectively pick what's relevant for your ephemeral rollup systems. We're kind of designing the system in a way that can run on sort of commodity hardware. So we don't run them on beefy machines, and therefore, like, there is a lot of optimization around what state is actually relevant for the subset of the accounts that you're writing. So that's one, and the same is for the other way around. Whenever you are syncing back state, there are like still challenges, in lending transaction or what typically you will call a sequencer, how you sequence all the updates and state transitions, and that open up obviously another big category of problems around how you prove state transition, how you prove that the validator is not malevolent, is not pushing just like an arbitrary state transition collusion, and any problem of this nature. There is I guess we don't have time. We can go deeper into that, but like it probably will take a couple of hours to summarize all the different approaches that exist today. Optimistic decay, solution in the middle. That's like another kind of very sophisticated and engineered AV part of the system. There are also a set of problems related to the deployment itself. The system obviously is optimized for executing transactions as fast as possible, but because of the collocation aspect, how you deploy the system also make a big difference in end-to-end latency. So you want to have a system where pretty much anyone connecting to the network have a machine that give him sub 50 millisecond latency, and that's like some challenges around how many instances, how to keep constant uptime, how to deploy in like a reliable way, and yeah, then there are all the challenges related to UX and DevX. How do you kind of abstract away the complexity of the system? How do you make it easy for developers to start and have like a hello world solution working in like 5-10 minutes max? And these are pretty common like challenges in Solana as well. So the great things about being like in the same ecosystem and pushing the same ecosystem is like we work in open source, we reuse the same SDK that Solana use, and we also contribute. So partially it's like a team effort, like a cross team and like a Solana effort as well. But obviously like there are challenges around the specifics of how you make it easy for developer to start using your system. And yeah, I guess I mentioned a bunch of categories, and you can imagine if you want, we can unpack some of those. But there are definitely a lot of interesting problems that we're working on.
That's awesome. Two things that I'm curious about. We could get into it. So you mentioned co-location, right? So is it, when you say co-locating, is it like co-locating with the validator? So what kind of use cases require co-location? Is it runs a perp stacks and then they need to co-locate, or?
Yeah. I mean, when I mention real time, just to define it more clearly, are all the use cases that require latency, which is like typically below 50 milliseconds. And latency specifically, I mean end-to-end latency. So from the time you send the transaction to the time you get back the result of your transaction, and that includes the state transition happening on chain and reflected that chain to anyone that is watching the same state. And this is like critical for where we started games. Obviously, like if you have more than 50 milliseconds or 100 milliseconds, your games start to lag, and that kind of break the experience for the user. But that's also true for high frequency trading, and I guess nowadays there is this huge narrative around CLOPs and how to achieve latency that is also in this range, and that's another use case where co-location is extremely important. And another use case that we are kind of experimented and getting like interest from a lot of projects is deepin. There are like different use cases. We're working like in a pilot with multiple projects that require like fast response times, and they are nowadays using the server for getting the latency that they need, and then they kind of batch or build in-house their solution for like posting periodically on chain. But that's like overly complicated, and they have a lot of issue on that front. So like that's when you could basically switch from that server architecture to ephemeral rollups, and yeah, I guess apps as well. Like if you imagine bring it on chain, other use cases, like it could be a social network, it could be apps that people use daily. Fast response times is kind of critical, and so any state transition becomes sort of critical in latency terms, and yeah, so that's why co-location matters in these use cases.
That's awesome. How do you the earlier when we were chatting, you mentioned the team is like now 17 members, right? That's like in the last span of 1 year, just like team has gotten so big. How do you how do you maintain like a high performance engineering culture at Magic Block?
Yeah, that's the 1 million question, and like it's I guess one of the complex part in running a company, like finding and retaining talent. Um, I think it's very important to do the right first hire correctly. First team members are gonna kind of compound the culture and the mentality of the company. And I think it starts with the founder first, like being like a very kind of transparent, product oriented. That's those are kind of things that we value. But like the first hire of a team are going to be critical, because then they are going to compound in like the next hires, and eventually they're going to compound in the company and eventually in the product itself. I have this impression that or this theory that if I use a product or a platform, I can probably get a sense of the team that is behind that product just by the look and feel and design choices, or if I use an SDK, I can kind of get a sense of, or I have the impression that I can get a sense of what are the people behind that, and so I really think it's critical to hire correctly in the first hires, and then like that's gonna simplify the next hire. I guess I can make an example. Like we were like our first hire was Thorsten, which is very kind of I guess known in the Solana ecosystem. He built SDKs and tools like Shanks and Solida that are widely used daily developer life, and it was also like a huge contributor on open source, and so it was like a perfect fit for us. It was like very very much aligned, and I think this kind of compounded in all the other people that joined the company afterward. Like everyone is kind of very passionate about open source, contributing, pushing the ecosystem forward, and yeah, that's like what I like to kind of maintain as a high bar. I guess it's more like a cultural fit to the company. In terms of engineering, I think the same principle apply. Common like knowledge of A player, get other A player, and so again, like if you pick carefully the first employees, then they're going to be part of the selection processes of the next people. Maybe they have a friend, maybe they interview someone, and they kind of get the sense that it could be a strong engineer, and so that's why again it compounds to the company. And I don't know if the question is more like about the process or how we hire. If it's interesting,
No, I think this makes perfect sense. I also especially being like a open source company working, a lot of your work output also goes out in the open, right? So I'm curious how do you weigh open source contribution heavily?
Open source is definitely a big plus. If anyone, like any candidate, has a strong contribution, it's a good signal that is going to be comfortable and aligned with the way we're working. As you mentioned, we're working in public repositories, so we're building in public, and that's like comfortable for people that are used to that workflow, but could also be uncomfortable to some degree if you're not used to that. Like all the issues, all the pull requests are public, so you are exposed to anyone, which is great. Obviously, we like that, but it could be uncomfortable for other people that are not used to build in public. I think that was like if a candidate is strong, doesn't have like open source contribution, is not a bad sign. Maybe they just like worked in a company where they didn't have the possibility to kind of build open sources. Sometimes it's not your choice, right? It's the company choice. If maybe you're working super cool stuff, but the company as a policy don't create open source, don't release as open source, then I don't think it's your fault, right? But anyway, like you will get the sense while like interviewing and having a conversation with the engineer if the work is something quite interesting. So yeah, I guess it's a plus, but it's not mandatory. One thing that I guess I notice over time is people that have a lot of side projects. They are usually a good fit for our teams. Mostly, I'm not sure if because we're like touching multiple things or because it's just like show that you're a builder, like you have a bias for kind of actions and just build stuff. But I feel like that's something that I value. Like one of the questions that I usually ask is like, what's the side project you're mostly proud of? Is there one that like you will be very, very proud, and do you want to explain what were the challenges, why you built it in the first place? And this is like one of the questions that give me like a good insight in the personality of a person, of a developer.
Are there any specific roles that you're hiring for?
Yeah. So different roles. Right now, like we're always looking for kind of strong Rust low-level engineer for the work on the optimization of the Ephemeral validator, and full stack as well, and DevRel that are more like on gluing together the infrastructure with who is building the apps in the games or financial products on top of the infrastructure.
That's awesome. If you can share after this, if you could share the job description, we will make sure to add it along with the video. We'll list it in the description so that
Absolutely.
the devs watching can apply.
Absolutely. Thanks.
Awesome. Thank you so much for joining us, Gabriele. And also, would you like to share anything about how people can get involved apart from the jobs? What can people build on top of Magic Block?
Yeah, absolutely. I guess two ways. One is building. Like you can just take the example or the tutorial that are available or on our documentation or on the GitHub repo, and try to build an MVP or a product on top of it. We occasionally do hackathon. We sponsor Colosseum, and so like if you want to join one of those, that's definitely like a good time where everyone is building and vibes are great for building a product. Otherwise, there's also the path of trying to go through the issues that we have open in the multiple repository. It could be at the SDK level or at the validator level, and try to look for first good issues and take it from there. It could also just be commenting or proposing an architecture. I guess that's a good way to start. We started releasing all the major design and architecture that we're going to implement as a GitHub discussion, what we call MIMD, like following closely the CMD of Solana. And so if you go there, you will find like outline, measure refactoring, measure like features that we're implementing right now. Any comment, any interaction there is welcome. And yeah, then any other like could be using the product, building a product, or contributing to the infra. Anyone is welcome, and yeah, looking forward to see more people contributing and joining our ecosystem.
That's fantastic. Thank you so much for joining us today, Gabriel. It's been such a fantastic conversation.
My pleasure.
Thank you so much. Thank you so much once again.
Thanks, Jack. My pleasure.